When we see incredible endurance feats, like ultramarathons or extreme free diving, we often wonder what hidden physical advantages these athletes possess. While a good lung capacity certainly helps for extreme endurance, it is actually the efficiency of your respiratory system, rather than just the sheer volume of air your lungs can hold, that makes the biggest difference. Think of your lungs not just as simple balloons that inflate and deflate, but as highly sophisticated air exchangers. The true magic, where oxygen actually enters your bloodstream and carbon dioxide is expelled, happens at the microscopic level within tiny air sacs called alveoli. These alveoli are intricately surrounded by a dense network of capillaries, which are the body's smallest blood vessels. For an endurance athlete, a highly efficient respiratory system means that their body can very quickly and effectively pull oxygen from the inhaled air and transport it across these delicate membranes into the waiting red blood cells. Simultaneously, waste carbon dioxide, a byproduct of muscle activity, moves from the blood into the alveoli to be exhaled. This crucial process is not just about the size of your lungs. It is heavily influenced by factors like the total surface area of your alveoli, the thinness of the alveolar and capillary walls, the density of those capillaries, and importantly, the concentration of oxygen-carrying hemoglobin within your blood. Endurance athletes rigorously train their bodies to maximize all these exchanges, ensuring that each and every breath they take is utilized to its absolute fullest potential. It becomes less about the sheer volume of air you can initially take in, and much more about how expertly and rapidly your body can process and utilize that air for sustained, extreme effort. So, what does this mean for an aspiring endurance athlete, or simply understanding these incredible feats? Rather than trying to artificially increase your lung volume, focusing on training methods that enhance oxygen uptake and delivery throughout your body is key. Regular cardiovascular exercise, like running, swimming, or cycling, strengthens your diaphragm and intercostal muscles, which are essential for efficient breathing. This type of training also significantly improves blood flow to the lungs and increases the efficiency of gas exchange. This concept is perhaps best encapsulated by what scientists refer to as VO2 max, which stands for the maximum rate of oxygen consumption measured during incremental exercise. While having a decent lung capacity certainly contributes to a high VO2 max, the measurement itself is more reflective of your entire cardiovascular system's comprehensive ability to capture, transport, and ultimately deliver oxygen to your working muscles. It is a critical indicator of aerobic fitness. Furthermore, an often overlooked aspect in extreme endurance is something called respiratory muscle fatigue. During prolonged, intense efforts, even the muscles responsible for breathing, such as your diaphragm and intercostal muscles, can become tired. When this happens, your body might actually divert blood flow away from your working arms and legs towards these fatigued breathing muscles, trying to keep them functioning. Highly trained endurance athletes develop respiratory muscles that are remarkably strong and resistant to this kind of fatigue, which means they can keep breathing hard without sacrificing precious blood flow to their powerful limbs. Ultimately, for incredible endurance, it is a combination of factors working in perfect harmony, with respiratory efficiency at its core. It is about maximizing every breath to fuel sustained effort, ensuring your muscles get the oxygen they demand, and effectively clearing metabolic waste. This optimized system allows athletes to push further and longer, continually redefining the limits of human potential.